A very good morning, one and all. In previous class, we have discussed about the edge detections and the texture analysis, and what are the types of edge detections like Sobel operator, pivot operator, Canage operator, and Laplacian of Gaussian, and their applications. And followed by the texture analysis and the types of texture analysis like structural features, model based features, and transform based features, followed by the applications. In today's class, we are going to discuss on the topic of binary morphology and gray morphology. In binary morphology is an powerful image processing technique used to analyze and manipulate the binary images where pixels are classified into two categories: foreground and background. Foreground is mostly focusing on the typically white images, and background images is typically based on the black images. It is based on the principles of mathematical morphology, which studies the geometrical structures of shapes within an image. Binary morphology is particularly useful for examining the form and structure of objects, helping them to simplify, extract, and enhance the specific image components. These operations work by probing the image with a small shape called a structuring element, which defines how pixels are added or removed based on their spatial relationship. The goal is to preserve essential structure while removing the irrelevant or unwanted parts like noise or minor defects. Basically, the binary morphology is useful for examining the image components and also to extract the unwanted things which are in the image and also to enhance their properties. And their major operations is nothing but their key morphological operations are dilation, erosion, opening, and closing. And what is the dilation? Dilation, it is an operation that adds pixels to the boundaries of white region, that is the foreground. As by adding the white region, what we are going to get the result is that the object in the images appear larger and thicker. This is especially helpful when trying to fill the small holes or connect the broken parts of an object. It is nothing but simplify. It is nothing but simply we are filling the black dots in an image or filling the some holes in an image. And what is erosion? Erosion does the opposites of dilation. It removes the pixels from the boundaries of a white region. And what we have seen is in dilation is we are adding some white region, but in erosion we are simply removing some parts from the boundaries of an image, causing the object to shrink and become more thinner. Erosion is often used to eliminate small white noise or separate the touching objects. And what is opening? An opening is a combination of erosion followed by dilation. It is mainly used to remove small noise or unwanted white spots from the image without significantly changing the size of the main object. This makes it ideal for smoothing objects outline and disconnecting weakly connected structures. And what is closing? And closing is nothing but reversing of opening. It involves dilation followed by erosion. This operation is used to fill small holes or gaps inside the objects or images, making the shape more solid and continuous. It is often applied in repairing broken parts of an image and smoothing their contours or their boundaries. And what are the major use cases is noise removal, object separation, and skeletonization. What is noise removal? What is a small irrelevant pixel clusters can be removed from binary images using opening and erosion operation, leading to cleaner and more accurate visual data. And what is object separation? When multiple objects are stuck together or overlapping, morphological techniques like erosion and opening help to split them apart, allowing for individual analysis and labeling. And what is skeletonization? This process reduces objects to their thin skeletal form, preserving their shape and connectivity. It is used in pattern recognition, character recognition, and medical imaging to study the structural framework of an object. Followed by the gray morphology. Grayscale morphology is also known as gray morphology, is an extension of binary morphological operations to grayscale images, where pixel values range across multiple intensity levels instead of being just black or white. It uses similar concepts from binary morphology such as dilation and erosion, but instead of adding or removing the pixel based on the shapes alone, it operates on intensity values, making it suitable for more complex and detailed images. Gray morphology is especially useful in enhancing image structures while preserving important visual features like edges, textures, and contours. And what are its key operations is nothing but grayscale dilation, grayscale erosion, and opening and closing. Grayscale dilation. In grayscale dilation, each pixel in the image is replaced by an minimum value of its neighborhood defined by its structure element. This operation tends to brighten the image and enhance their lighter feature, expanding them outward. It is helpful in highlighting the brighter region and filling the small dark holes or gaps. Grayscale erosion. This erosion operation does the opposite. It replaces each pixel with a minimum value of its neighborhood. By adding that, as a result, we can get the darker features are intensified and expanded, while small brighter spots are reduced or removed, completely removed. This is useful for suppressing noise and unwanted lighting details in the images. And what is opening and closing? Grayscale opening, erosion followed by the dilation, is used to smooth object outlines, remove small bright details, and flatten uneven background region without significantly altering the main shapes. And grayscale closing is nothing but is used to fill the small dark gaps, connect to the fragmented bright region, and make the overall structure of the object more coherent. And what are the major applications is it's usually majorly used in the applications of medical image analysis, texture smoothing, and the feature extraction. In medical image, grayscale morphology is widely used in analyzing X-rays, MRIs, CTs, and ultrasound images. It helps in enhancing specific tissues, detecting tumors, and refining organ boundaries for accurate diagnostics. For the texture smoothing, in complex images where texture may be uneven or noisy, grayscale opening and closing operations help to remove the irregularities and smoothing of the texture, making further analysis more efficient and accurate. And the feature extraction can highlight or suppress the specific intensity feature, making it easier to extract the edges, contours, or region boundaries in grayscale images. This is useful in object tracking, character recognition, and the machine vision system. So, in today's class, we have discussed about the binary morphology and grayscale morphology and what are their key roles and their applications in it. Thank you.